Let's look at factoring by grouping. I've got x cubed plus 5x squared plus 7x plus 35. Now, none of these things have a shared number, like 5 goes into the 5 and the 35, but not everything. They don't all have x, a lot of them do, but not all of them. So I don't really have a greatest common factor that I could pull out. So one strategy is I can try to group together things that look similar and then factor out small pieces. And maybe, if I'm lucky, there's going to be something that they have in common after I do that. Now, this is really just an exploration. I don't know for sure if this is going to work, but it is something that I can attempt to do when I have 4 more terms. So I'm just putting parentheses around two sets here. I'm putting around parentheses around this x cubed plus 5x squared and this 7x plus 35. Reason why I'm doing this is I'm seeing these both have x things in common. These both have 7 things in common. So for this first piece, I can say, all right, x squared goes into this, x squared goes into this. I can pull out x squared, the greatest common factor, for those first 2 terms. X squared times x would give me an x cubed, and x squared times 5 would give me 5x squared. So I'm factoring really just pieces of this, and I'm trying to see if I have any shared pieces. Okay, I'm going to do the same thing for the second set, treating it like it's its own problem here for a second. I've got 7x plus 35. And I'm thinking, all right, well, 7 goes into 7x, and 7 also goes into 35. So I can pull out a greatest common factor of 7. 7 times x gives me 7x. I'm always checking by multiplication to see if things are working out. And 7 times 5 would give me 35. So this is how I start to try by grouping. I just group together really any 2 sets of 2 here, and I see what happens if I pull out their GCF. And sometimes I get really, really lucky in that I will have a common piece after I do that. So these both have an x plus 5 in common. So I can factor out that x plus 5. When I'm factoring out that x plus 5, I have to think, well, what's everything that the x plus 5 is hitting? And it looks like the x plus 5 hits this x squared. And it also looks like this x plus 5 is with 7. So if I factor out x plus 5, I get x plus 5 times x squared plus 7 gives me this expression here. Now you might be wondering, well, what if I tried to group things a little bit differently? So let's say instead of doing it this way, starting out with the same expression, let's say you're looking at this 5x squared and you're thinking, well, 5x squared and 35, they look like they have 5 in common. So let's group together x cubed and 7x. They both have some x thing going on with them. And let's group together the 5x squared and the 35. And maybe this will work and maybe it won't. This is just a strategy. It's something that I'm trying now. These first 2 pieces, they both have an x. So I'm going to pull out an x. X times x squared gives me x cubed. So my powers are adding. That's looking good. If I'm pulling out the x here, I still have the 7. For this piece, these both have the number 5 in common. 5 times x squared would give me 5x squared. 5 times 7 would give me 35. When I do this, I'm hoping that I end up with a shared expression, and I do here as well. I get that x squared plus 7 in common. So pulling that to the front, x squared plus 7. And it looks like x squared plus 7 was paired up with 2 different things. It looks like it was paired up with the x, and it looks like it was paired up with a 5. Looking at my end result, I have x squared plus 7 times x plus 5. So I end up with the same end result here. So if you're looking at practice examples of this stuff and you're wondering, well, how do I group things? you actually have a lot of flexibility. So just try any pair of two things and see if that works in your favor. And you might be surprised, it might work. So I hope this is helpful here. This was factoring by grouping.